Okay, so here's the kind of messy spreadsheet that we want to import into R and convert into a longer form. And the form that we want, we would just like to have age, year, gender, and count. Just a very simple, long form. And let's look at all the problems that we have with this spreadsheet. First of all, there's a bunch of rows of junk at the top that would cause us trouble. Second thing, down at the bottom, you notice that instead of a pure number here in row 95, we have 85 plus, which means that these are all the people who are either 85 or older than 85. And then we have total. So we're going to want to get rid of this row. And we want to get rid of this plus symbol here. Okay. So how did I do this? Well, it actually turns out to be fairly easy. I just clicked on the import control, and I selected to read an Excel file. And the only change I had to make was to set the skip rows to 7. Okay, and that worked. And I'll show you the results. Oh, I also included a library Plotly because of something I wanted to do at the end. And I'll show you how we use that. This is basically the only command that you need to bring in that spreadsheet. Then I looked at it. Of course, we can't do it here. Then I wanted to fix the age column, and I want to remove the row which begins with total. I want to change 85 plus to 85, and I want to make age a numeric variable. So here we go. OFM forecast is equal to OFM forecast, and then filter. Age is not equal to total. That'll eliminate that entire row. Mutate age equal if else. There's a Boolean age equal 85 plus. If that's true, then you change that to 85. Otherwise, you accept what is in age. And then you make the last part of the mutate is to make age equal as.numeric age. Then we only want the rows, or only want the columns which actually have genders. So OFM forecast is OFM forecast, and then select does not start with the word total. Then we do the pivot longer, and this is the trickiest thing. I had to do a little Google research to see how to do this, because we have gender and year as a single column label. So in doing the pivot longer, we want all the columns except for age. The names to is a vector, the C of gender, comma, year. And the things that separate the names is the blank space. And the values to equal count. Then we have age 18 by year. Okay, well, at this point right here, I have succeeded in doing what I wanted to do. And I just wanted to show you a simple application of this. I'd like to look at the number of 18-year-olds in the state of Washington. And I'm only interested in the future. So I take the long OFM forecast and I filter for age equal to 18, group by year, summarize the totals. So what that gives me in age under 18, I have two columns. I have the year column, and I have the sum of males 18 years of age and females 18 years of age. And I have to turn off these views in the HTML because you can only do view when you're sitting in RStudio. Then the interesting application of this is to look at what happens to the number of 18-year-olds. And I'm only interested in years after 2020. And you notice it's climbing fairly steadily. until you get to like 2930. Then it goes through a period of decline. 2035, 2036 about the same, and a brief period of climb, and then whoop, wow, 2040. What happened? What is the story with 2040? Well, actually, 2039. This is 18 years after 2021, and what you're seeing here is the impact of births in the year of COVID. Basically, your 18-year-olds are the number of people who were born 18 years ago. And in Washington, that would be declining, except for the fact that in Washington State, you always have some net in-migration. Okay, so that's the story with importing that data frame.